In this video and in the next, we are going to integrate this. We're going to do it using the partial fractions method, and then later on we're going to integrate it by using trigonometric substitution. Both should lead us to the same answer. So in this video, we're going to tackle this method. In the next, we will use this method, but both should lead us to the same answer. So let's try and use this method here. So start out by noticing that whenever you get given something that's easily square rootable, and there happens to be a minus in between, then you can always break this up as x plus 1 and then x minus 1. So you can always rewrite this in this form. Well, if you rewrite this in this form, you can always break this up into two fractions, into one fraction plus another fraction. At the moment, you've got this thing times this thing here. It is possible to break this up, so you have one thing plus another thing. But your job is to find out a and b such that this will always be the same as this. So if I were to give you this plus this, to merge the two fractions together, you would get the two denominators to be the same. So you would times top and bottom here by x minus 1. Times top and bottom by x minus 1. For this fraction, you would times top and bottom by x plus 1, x plus 1. So this thing here will then become this. This thing here will then become this. Notice that the two denominators are the same, so you can merge these two fractions. So merging the two fractions will then give you this. Remember, your job is to find a and b such that this will always be the same as this. So the trick is to concentrate on the numerator. The trick is to concentrate on the numerator. So concentrate on finding a and b such that this thing here is always equal to 1. Well, once you're at this stage here, if you look at this, if you set x to be 1, if you put 1 into here, then this thing here will be 0, making 1 equals this thing here, making 1 equals this thing here. So b is a half. Now looking at this thing here, if you put a negative 1 into here and into here, so let x equals negative 1, this whole thing here would disappear. This thing here will be negative 1 take away 1. That would be negative 2. So a would be negative half. So now we've found our a and b. So we can just put this into here and put this into here. So going back to this, we can put this into our a, we can put this into our b. So that will then give us, hang on, that will then give us this. Because if you look at this, hang on, if you put this into b, it will be a half. So this is b here divided by this thing here, x. So you would visualize this as a half divided by x minus 1, and then it gets multiplied to the bottom. So that would be a half over, so that would be 1 over 2x minus 1, and so on. So that will then give you this. You can actually factor out a half here. So this thing here, you can actually do this, and then 1 over x minus 1 minus 1x plus 1. So you can factor out the half. So this is a constant, so you can actually take it out. Well, anyway, for this thing here, you can rewrite it as this. So this thing here is exactly the same as this, but just written differently. So now once it's in this form, it's easy to integrate. Notice that this thing here is a derivative of this thing here. So whenever you have something being the derivative of another thing, then you should think about the natural log. So if you're trying to integrate this, if I were to give you differentiate x minus 1, you would go 1 over x minus 1 and then times the derivative of the bubble itself, which would be 1, because this thing here is 1. So, well, if you integrate this, it will then give you this. Integrate this, and it will then give you this. In the next video, we will use trigonometric method, but currently this is our answer. It should lead us to the same answer. So in the next video, we're going to use trigonometric substitution. Okay.